Welcome to Daily Papers, the podcast where we break down fascinating new research papers so you don't have to.
Today we're talking about a classic problem, not just in science, but in life. How do you get what you really want when you're not even sure how to ask for it?
Right, it's like using a genie. You get 3 wishes, but if you're not super specific, you could wish for $1,000,000 and end up with 1,000,000 male deer in your living room.
Exactly. And it turns out that's a huge problem when we try to use artificial intelligence for scientific discovery. We're telling these incredibly powerful AI genies what to do, but we might be wording the wish all wrong.
And the paper we're looking at today offers a solution. It's called Accelerating Scientific Discovery with Autonomous Goal-Evolving Agents, and it basically describes how to build an AI that doesn't just grant the wish, it helps you figure out the perfect wish to make in the first place.
So let's set this scene. Right now, if a scientist wants to use AI to, say, design a new drug, they give the AI a goal. In the tech world, they call this an objective function.
It's basically just a scorecard. The AI tries to design millions of different drug molecules, and the objective function gives each one a score. Maybe it gets points for how well it kills a certain bacteria and loses points for being toxic to human cells. The AI's job is just to get the highest score possible.
Sounds straightforward. What's the problem?
The problem is that these scorecards are almost always what the paper calls imperfect proxies. They're a stand-in for what we really want, but they're not quite right.
Okay, what does that mean in practice? Give me an example.
Let's stick with designing an antibiotic. Your main goal, your objective, is to kill bacteria. So you tell the AI, goal number 1, make a molecule that's great at killing bacteria. The AI goes off and designs a molecule that gets a 10 out of 10 on that objective. Fantastic.
So we've cured all diseases?
Not quite. The scientist looks at the winning molecule and realizes it's soap. The molecule is literally a type of soap. It's great at killing bacteria, but it's completely useless as a medicine.
Ah, the AI did exactly what it was told, but not what the scientist actually meant. This is a classic issue called reward hacking, where the AI finds a clever loophole to max out its score without achieving the real unspoken goal.
Exactly. So the scientist has to go back and add another rule. Okay, AI, kill bacteria, but also make it drug-like. Then the AI might come back with something that's drug-like and kills bacteria, but is impossible to actually make in a lab.
So the scientist has to add another rule for synthesizability, and on it goes. The process of discovery gets bogged down because the human is constantly having to tweak the AI's goals.
This is where the new system, which the authors call SAGA, comes in. SAGA stands for Scientific Autonomous Goal-Evolving Agent, and the name says it all. The goals themselves evolve.
So it's not just a problem solver, it's a goal setter.
Precisely. SAGA has a really clever 2-level structure. Think of it like a fast-thinking worker and a slow-thinking manager.
Okay, I like that. The fast worker is the part we already know, right? The optimizer that just tries to get the high score based on the current rules.
Yep, that's the inner loop. It generates thousands of potential solutions, molecules, materials, whatever it is, and scores them. But then the outer loop, the slow-thinking manager, kicks in.
And what does the manager do?
The manager is actually a team of AI agents. First, there's the analyzer. The analyzer looks at all the molecules the worker just made and writes a report. It might say, hey, we're getting great scores for killing bacteria, but a lot of these look like soap and are probably not good drugs.
So it spots the problems just like a human scientist would.
Then that report goes to the planner. The planner agent reads the analysis and says, okay, I see the problem. We need a new goal. Let's add an objective to measure drug-likeness.
And once the planner decides on a new goal, someone has to turn that idea into something the fast worker can actually use, right? A new piece of the scorecard?
That's the implementer agent. It literally writes the code for the new scoring function. Then this new updated set of goals, this new scorecard, is handed back down to the worker in the inner loop, and the whole process starts over.
Wow, so the AI is in a constant loop of working, analyzing its own work, and then changing its own instructions to do better next time. It's automatically refining the wish.
And it's incredibly effective. The paper shows Saga succeeding in a bunch of different areas. In antibiotic design, it managed to design novel molecules that were potent against drug-resistant bacteria, but were also safe, stable, and actually looked like real drugs, not soap.
That's amazing. What else did they try?
They used it for material science. They tasked Saga with designing new permanent magnets. The initial goal was just to make them have high magnetic density, but Saga's manager loop realized that the best magnets were using rare, expensive elements, which is a big supply chain risk.
So it added a new goal.
It added a new goal to minimize supply chain risk, and it ended up discovering materials that were both highly magnetic and made from common, inexpensive elements. It also designed new super hard materials for things like precision cutting tools.
It's so interesting because it feels like it's mimicking the actual scientific process. A scientist doesn't just set a goal and work blindly for years. They're constantly observing, reevaluating, and changing their approach based on what they find. Saga is doing that automatically.
And they've built it to be flexible. You can run it in co-pilot mode, where the AI manager makes suggestions and a human scientist gives the final approval, or semi-pilot, where the human just gives feedback. Or you can put it in full autopilot and let it run the whole discovery process on its own.
So what's the big takeaway here?
I think it's that the future of AI in science isn't just about creating tools that are faster or more powerful at churning through data. It's about creating a true collaborator.
An AI partner that doesn't just answer our questions, but helps us ask better ones. It stops being a simple genie in a bottle and starts becoming a fellow scientist in the lab.
Exactly. It's a system that automates not just the search for the solution, but the search for the problem itself. And that could fundamentally change how we discover things.
That's all the time we have for today. Thanks for tuning in to Daily Papers.